Hello and welcome. My name is Misty, and we're here to talk about some Oxy Fuel welding, cutting, um, especially some of the equipment setup and operation. We're going to have a couple of different things that we want to talk about: how to maintain the major components of an Oxy Fuel welding equipment, how to test for leaks, setup, lighting, adjusting, extinguishing, and disassembling the Oxy Fuel system safely. Understand the chemical reaction that takes place in the oxy fuel and advantages and disadvantages of different types of fuel gases. Here we go. So let's start out. So oxy fuel is a general grouping of a bunch of processes which all burn a type of fuel gas and oxygen. There's a certain basic equipment that is common to all oxy fuel welding: cylinders, regulators, hoses, hose fittings, safety valves, the torches, and the tips used, okay? This process needs a good understanding. So if you're not sure how to use this process, I cannot express enough. Get properly trained, go to your instructor so you don't hurt yourself or others around you. Remember, this is something that's not to be experimented with, so all the oxy fuel systems have very similar equipment and they're operated in a very similar way. The first thing we're going to talk about is pressure regulators. Pressure regulators take the high pressure from the cylinder or the manifold system and turn it into a lower system that you can work with. It's important to remember that the regulator keeps the lower pressure constant while being able to change it to the flow rates that are needed. It is imperative to understand that all regulators work in the same way, but some regulators are specific for different types of gases or different pressure ranges. Using one that's made for a different gas or other than its intended purpose could cause a fire or explosion. So we're just going to get that out of the way right away, okay guys? So a regulator, how does it work? Well, let's take a look at this. A regulator works by holding a diaphragm with forces on both sides and keeping it in balance. So this is the diaphragm and it's flexible, okay? So the size of the regulator is determined by the ability of how much working pressure it can stand. So the adjusting screw pushes forward. This is the adjusting screw, and it pushes forward on a spring that pushes this diaphragm, which pushes this little valve in and out. How much little or how much more do you want of the gas? Okay, it's a very simple system and it can get kind of complex as we go along. So when the gas pushes against the diaphragm and equals the same pressure, the valve closes. Pretty cool, right? Now, when there's a drop in the pressure, like when the torch valve is opened and gas starts to flow through the regulator is constantly trying to make an equal pressure on both sides of the diaphragm, ultimately giving us the pressure that we dialed in on the gauge. So here's one that's been cut in half, okay? This is a two-stage regulator. Two-stage regulators are able to keep the pressure constant at a very high or very low rate, even as the gas cylinder empties and the pressure drops. So in our example, let's see if you can see, here's a diaphragm here, and we have two springs, okay? So regulator gauges, this is important to understand. There can be one or two gauges on the regulator. Usually there's one gauge that gives the cylinder pressure or how much is in the tank, okay? And on average, a cylinder can anywhere be from 200 to 4,000 psi, okay? The other gauge is working pressure, or how much pressure is going to come out of the cylinder, okay? So this is our working pressure. This is how much do I want to come out, okay? This one is how full is my tank, okay? Now, here's a single stage regulator, has a single diaphragm. Here's our spring that attaches to our adjusting screw, and this goes in and out. So we can see the difference in a single stage regulator. It has only one diaphragm. This type of regulator will have a single gauge to give you only the pressure of the cylinder. So many times you can also have a flow meter attached to this type of regulator, and then the flow meter would take that flow from the regulator and turn it into a usable pressure that you can use. Okay, so they're usually pressure release valves. They're used when the regulator can no longer hold the pressure. The pressure will then dissipate the excess pressure. So there are a couple different types of regulator safety pressure releases. Okay, the first one is a ball and a spring. When the pressure becomes too great, the spring is compressed and opens a safety valve. So here it is. The spring compresses and opens this valve here, and it goes psh. Okay. The other type is a safety disc. This is made of a really, really thin metal, and they put it between these two little seals. And when the pressure is too great for the little piece of metal, bink, it pops open and out it goes. Psh. You know, there's also other safeties on regulators. The gauges on the front will also blow out forward. This is why you stand to the side when you open a cylinder with the regulator on it. Okay, so the maximum working pressure of acetylene is 15 psi. That is 1.5. Acetylene becomes unstable over 15 psi and can blow up. So it is shown on most acetylene regulators with a red line or an area, as we can see right here. We have this red line. Okay, it says, hey guys, what are you doing? So regulators don't have any moving parts that require any type of oiling. Oiling a regulator is very unsafe and can cause fire and explosion. This means that you should also have clean hands. Having oily or greasy hands can do just the same. It can cause fire or combustion on your hands or your clothing. Okay, so be sure to back off the pressure adjusting screw after the system is shut down. This goes for all types of regulators and all types of systems. When you take off the pressure, it releases the spring and the diaphragm pressures. If you keep the pressure on those parts all the time, it can cause damage and wear. So regulators have what we have is called creep, where the regulator doesn't stay at the set pressure. So some pressure release is expected, maybe a pound here or two, but for it to go up or down excessively, this can be bad and unsafe. Should you find a regulator like that, take it out of service and have a qualified trained repair person check it out. Regulators are a very sensitive piece of equipment. Even as an inspector, I don't mess with it. If you don't know how to repair it, do not. That being said, regulators should be kept from getting banged around or dropped because, of course, we can damage the internal components like that little diaphragm inside. So remember, regulators should also be kept away from flame or sparks. It's kind of like that little baby. Okay, so different types of gases have different types of fittings. So as we can see, an acetylene cylinder has a reverse thread here. Okay. This is done so you don't put the wrong regulator or pressure on the wrong gas. And we can see that each type of gas has different types of threads and fittings. All right, let's talk about some cylinder and regulator fittings. Okay, so these are adapters that can help with regulators and putting them onto a cylinder. So certain fittings can be used. So what we have here on the left is an acetylene cylinder adapter. Sometimes, the threads are different from the regulator that we have, or maybe we're going from a smaller tank to a larger tank, and sometimes we need an adapter there. The other one on the right is a little bit more common. It's a carbon dioxide to argon adapter. So what happens is sometimes we'll have a 75-25 mix, and it either has a CO2 fitting, or it might have an argon fitting. And since our regulators are interchangeable between CO2 and argon, some regulators might not be correct for the cylinder that you're using. Okay, so fittings. We want to remember to keep fittings to the cylinder, the hose, and any other fitting that's in this system free from dirt and oil. We want to make sure that the fittings, they fit freely by hand, and we only want to use light pressure with the wrench, just enough so it's leak tight. So rather than wrenching it down like Hercules, we can do a couple of different things. Teflon, it can be used in some instances. Teflon cannot be used on oxygen because Teflon is a byproduct of petroleum, and petroleum is AKA oil, so we don't want to blow up. So not a great idea for oxygen. So if the threads or the seat of the fitting or the regulator are damaged, it needs to be repaired by a qualified technician, aka not you. So in some cases, when the damage is so great, you just have to trash it and get something new. You need to remember, these fittings are brass. It's very easy to cross thread, so you want to make sure to take the time to put the threads on correctly. Make sure your regulator's on right, and that way you don't have any issues. Okay, so we have what are called left-hand thread or reverse fittings, and they are identified with a little notch, as we can see right here, and right here. These are left-hand thread or reverse thread, and that notch is called an angular notch, and it tells the user that this is a left or reverse thread. I think it's a pretty good idea. This brings us to the end of part 1. Please stick with me, and we got a couple more parts to go. As always, take care.
Well, the world.